Hi. In the part 2 of examples for section 2.3, we're going to continue verifying some of the arguments and their validity. First, let's verify that modus tollens is actually a valid argument, and we're going to do that with the truth table method. So well, let's build a truth table. We're going to have P, and then Q, and then true, true, false, false, true, false, true, false. Then we're going to have P implies Q, which is our first premise. Premise 1. We have true, false, true, true. Then we're going to have negation of Q as our second premise. This is premise number 2. And we're going to have negation of P, and that's going to be our conclusion. So negation of Q goes false, true, false, true. And negation of P goes false, true, false, true. Okay, so now let's look for critical rows. This is true, false, no critical row, false, true, no critical row, true, false, no critical row. So we only have one critical row, which is this one. You see all the premises are true and true. And we're good because then the conclusion is also true. So this means that this is a valid argument. Now, question number 10 is determine whether the following argument is valid. If invalid, detect the fallacy. If the algorithm is correct, then the output is accurate. The algorithm is not correct, then the output is not accurate. Notice that this is a P implies Q type of argument. Premise number 1 is P implies Q. Then premise number 2 is not P. And then the conclusion is not Q. So this argument is invalid because this is talking about the inverse error once again. This is an inverse error type of argument. So unfortunately, it's not going to be valid. Okay, moving on. Let's go to question number 11. Question number 11 says, true or false, and display your reasoning. A valid argument can have all false premises and a false conclusion. Yeah, that can happen. This is true. So one example of that is, consider this: all birds are mammals. All birds are mammals. That is, of course, going to be false because birds are not mammals. So this is false. Now we're going to say all mammals have wings. This is another statement that is false. Therefore, in conclusion, all birds have wings, which is also false. Okay, so notice the structure of this. All birds have are mammals. This is an argument of the P implies Q nature. Why am I losing? Okay, this is from the P implies Q. Birds and all bits are, if X is a verb, then X is a mammal. This is a type of a statement in that way. Now, Q implies R. If X is a mammal, then X have wings. This is Q implies R. And finally, this will mean if X is a verb, then X have wings. So this is a P implies Q, Q implies R, and finally P implies R type of argument, which is transitivity argument. So you can see that everything is false, but because we have an implication, you know that false implies false is true. So the whole thing, the whole argument is going to be true. Now, number 2 if an argument is valid and all present premises are true, the conclusion must be true. Yeah, this is a something that is the argument of validity. If I have something of P implies Q, and or I have, let's just simplify this. If I have premise number 1 and premise number 2 and then conclusion, and if this is true, and the whole thing is true, it gotta be because the conclusion is true. This whole argument only works if the premises all are true, then there's no way that the argument is valid if the conclusion is false. This needs to be true. Now, an argument with true premises and a true conclusion will always be valid. This is false. Okay? So the premises and conclusion can all be true by coincidence, even if it's an invalid argument. For example, if it's raining, the ground is wet. The ground is wet. Therefore, it's raining. Even if all these three statements are true, which they can be, the form of the argument is not valid. This is a P implies Q, given Q, and so conclusion P, which is this is the converse error. Okay? So the structure of the argument has nothing to do necessarily with the fact that these are all true. So we can only have that if the premises are true, then the conclusion must be true to have a valid argument situation. But if the argument structure is incorrect, then regardless if the sentences or in each initial premise is going to be true, then the argument by itself is not going to be valid. Your premises are true. Now, it says the converse error is a valid argument form. And that we know that that is false. Yeah, we know that we just discussed that from here. The converse error is P implies Q. Then we have Q, then P. This, we know that this is invalid. And we tested this with, in video number 1, we proved this with the truth tables. Okay? Now, 12. Consider the following argument. If it's Monday, then I have class. If I have class, then I need my textbook. If it's Monday, then I need my textbook. Well, notice that this is a P implies Q, Q implies R, and then the conclusion is P implies R. If we want to write this argument in symbolic form, this is the way that we call it, and this is the transitivity argument. Once again, is this argument valid? Yes. And you can do this in many ways. You can prove it by doing the table if you want to. This is pretty long. We did prove it in the past in our previous videos. So make sure to check on how to build the truth table for this and how to prove it. Now, question 13 says, construct a valid argument using modus tollens with the following statement. The server is running. Q, users can log in. So, okay, so modus tollens, if you remember, is P implies Q, negation of Q, then negation of P. So we can just simply say users cannot log in. So if the server is running, then users can log in. and then this is premise number 1. Premise number 2 would be users can't log in. And so the conclusion would be server is not running. And that is that will be a valid argument, just because most stolen by itself is a valid argument. Now, create an invalid argument that commits the converse error. Use the statement about everyday situation. So we can use again one example of if it's raining, then the ground is wet. We can go. Let's remember the converse errors first. So P implies Q. Q. Conclusion P. This is the converse error. So we can say if it's raining, the ground is wet, and this is a P implies Q kind of argument. Then we can say the ground is wet. Therefore, conclusion, it's raining. Okay, and so this has the converse error, and is going to be an invalid argument in this form. Now, number 15, explain why the following argument is invalid. If I exercise daily, I will be healthy. So P implies Q. I am healthy, Q. Therefore, I exercise daily. So once again, converse error. Okay? So probably at this point, I have drilled into your head the converse error. Remember, you can also have the inverse error, so you can practice with the inverse errors as well with this. But for now, this is the end of the examples for section 2.3.